In this lesson, we will be looking at very special trinomials. They are called perfect square trinomials. If you can recognize them, it will save you some time. Where do they come from? Well, let's review on how to square a binomial. If you remember from a previous lesson, we learned if we square a binomial by writing it out twice, and then we FOIL. These are not conjugates, so the middle term does not cancel, but the middle terms are exactly the same. When we do that, this is a perfect square trinomial because it came from squaring a binomial. So how can you determine if it is a perfect square trinomial? The first question, are the first and last terms positive squares? That's a perfect square, that's a perfect squares, and those both have to be positive. Now, you have to check the middle term. That's probably the hardest. Okay, so if we take the square root of the first term, meaning what times what is 9x squared, 3x times 3x, and the square root of the last term, what times what is 4, 2. And we multiply these together, then multiply by 2, or I might say double it. Is that the middle term? And if the answer is yes, then it is a perfect square trinomial and we can factor it as a squared binomial. Sometimes this is harder than it's worth, but it will save you some time if you happen to recognize it. So let's just go through some examples. Let's first of all, can we know if they're a perfect square trinomial? So you look at the first and the last, they're both positive, they're squares. Now we have to check that middle term. So what times what is 9x squared? 3x times 3x. What times what is 25? 5. And if I multiply that together and then double it, multiply it by 2, do we get the middle term? And now the middle term can be positive or negative, it doesn't matter. So this answer is yes. Notice we haven't factored it yet. We're just going to see, are they perfect square trinomials? Right? Perfect square positive. 5x times 5x is 25x squared. 4 times 4 is 16. If I multiply that together, times 2, do you get 40x? Yes, you do. Positive squares. 3x times 3x is 9x squared. 2 times 2 is 4. If I multiply those together and then double it, do I get the middle term? No, I don't. So that is not a perfect square trinomial. Now, how do you factor it if it's a perfect square trinomial? Well, that's the easy thing. Once you figure out what it is, and you've written down those two things, the square root of the first one and the square root of the last one, you would put those in the parentheses. And then whatever that sign is, that goes there, put a squared. And that would equal to that one. So let's look at this one. Well, I took those two, so I'd have 5x, a 4, what's that sign right there? A plus, put a squared, and that's the answer to that one. Now since this one wasn't a perfect square trinomial, we're not going to look at how to factor that yet. So let's practice factoring. The first thing we check to see, is it a perfect square trinomial? Is that a perfect square? Is that a perfect square? Well, 8x times 8x is 64x squared. 3 times 3 is 9. If I multiply those together, 8x times 3, that's 24x, and then multiply that times 2, do I get that middle term? And remember, the middle term can be positive or negative. So yes, it is. And then whatever that sign is in the middle, we put that in the middle of the parentheses, and don't forget to square it. Very easy. Right? Perfect square, perfect square. So 5x times 5x is 25x squared. 7 times 7 is 49. If I multiply 5x times 7, I get 35x. I've got to double it. Is that the middle term? Yes, it is. Whatever that one is goes in the middle of the parenthesis, and don't forget to square it. Again, will save you a lot of time if you recognize the fact it's a perfect square trinomial. Let's look at number 3. Well, 4x times 4x is 16x squared. 1 times 1 is 1. If I multiply 4x times 1, I get 4x times 2 is 8x. So yes, that's a perfect square trinomial. Put that sign in the middle and square it. Now number 4, well, those aren't perfect squares, or is it a prime? No, I have to always remember that GCF. Is there a greatest common factor between all of that? Yes, I think a 3. They all are divisible by 3. Oops, 3 goes into 18, not 9 times. 3 goes into 18 6 times, but 3 does go into 27 9 times. Now, what do I have left? Well, I have a trinomial. It has a leading coefficient of 1, so I could go back to that other lesson and say, well, what multiplies to get 9 but adds to get positive 6? I know that's x times x at the front. Again, what multiplies to get 9 adds to get 6. Well, that's plus 3 and plus 3. 3 times 3 is 9. 3 plus 3 is 6. So that is an okay answer. But what if you say, no, 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 I think it's a perfect square trinomial because x times x is x squared, 3 times 3 is 9, and if I multiply 3 times x and then multiply it by 2, I get the middle term of 6. And I wrote my answer like that. That is also correct. Both of these are the same answer. We approach the problem 2 different ways. Always look for that GCF, and then if you think it's a perfect square trinomial, just check it out. Don't forget to check to make sure it's a perfect square trinomial by going through these steps.